All right, hi guys. One problem we're going to look at today. In our last video, we looked at some simple harmonic motion, something on a spring going up and down. Today we're going to model a different type of behavior, and this would be the behavior of the amount of daylight that we get throughout the year in, well, I guess anywhere in the world, but we're going to pick the city of Minneapolis. Okay, especially this time of year, we tend to notice like, wow, we get a lot more daylight now than we did a month ago. We get a lot more daylight today than we did a week ago. Okay, we can really notice that this time of year, the amount of daylight that we get is changing, and it's changing really quickly. Whereas in the winter, we don't notice it much. We notice that we don't get a lot of daylight, but we don't really notice it change a lot. And the same in the summer. Like the days are long, but it's hard to notice changing. Okay, so we're going to end up modeling this. This is a sinusoidal behavior that we have with daylight. Okay, and I'm going to bring you to a website here. I just did a search for daylight hours, and I'm going to choose sunrise and sunset times in Minneapolis, and it gives it with the time and the date. So when we take a look at this, here we go. Okay. Down here in the chart for each day, it gives the time of sunrise, the time of sunset, and the length then of daylight, and that's what I'm interested in this one. Is how much daylight are we getting. And notice these pluses here. This means that there is a difference from the day before of 3 minutes and 6 seconds. So if we find, like today's date, what is it today, the 25th? 26th today. We notice that we've gained 3 minutes and 8 seconds of daylight from the day before, so it's changing quite a bit. In this, we can just jump to any month we'd like. If we want to jump to, let's say, December, let's hit go. Here's what we're going to notice. We're going to notice minuses because we're losing daylight in September. And then something happens partway through. Oh, here we go. Right here, we notice it goes from losing daylight to gaining daylight. Okay, that would be the bottom of our sinusoidal curve. Oops, didn't mean to click that. There we go. So let's model this. What I'm going to do, like I like to often do, is sketch what the graph looks like, and then we'll come up with the function. All right, and you know what? I'm just going to, I think I want to get rid of that. This is not going well. Let's start over. Okay. I'm going to make a lengthy graph. Okay. And I could start with cosine. I could start with sine. And this one, I want to just start with a sine function. Okay. And I'm going to just draw a sine function there. Not perfect, but we got our 5 favorite points there. Now, what do we know about daylight during the year? When do we have the most daylight? When do we have the least amount of daylight? Well, we just found the least amount of daylight, oops, right here, okay, where we lose daylight. Okay, we're down to 8 hours and 46 minutes of daylight, and then it starts to increase again. Okay, that's our low point. So December 21st has got to be right here. So I'm going to write that as 12:21. And how much daylight did we have there? We had 8 hours and 8 hours and 11 seconds is the lowest I found. Now, when we have, 8 hours, 46 minutes and 11 seconds. We're dealing with hours, minutes, seconds here. That's not going to work. We need to just use hours. So I'm going to figure out what 46 minutes out of the hour is as a decimal. 0.76 repeating, so 0.77. So here we have 8.77 hours on December 21st. When do we get the most sunlight? When do we get the most daylight? Well, that happens at June at summer solstice. So let's jump to June. Let's find that most daylight. Okay, adding, subtracting. There we go. So we get the most daylight here on June 20th. And how much daylight do we get there? 15 hours, 36 minutes, let's say 37 minutes, because that's going to round there. So that's going to be 15.62 hours of daylight. All right, how about this point? How about that point? Well, that is going to be when we hit our equilibrium, which is what? When do those happen? Well, this happens when, let's see here, when we're at spring right about right now, and this happens in September when we switch from summer to fall. We were at that one actually not long ago. We should have probably just grabbed it then. Okay, let's go back to March. And when is it in March that we go from winter to spring? Where do we cross over that threshold? What is the date on that? What do we call this? Spring, is it called spring solstice? There we go. Spring solstice 2020 was Thursday, March 19th. Okay, apparently at 10:49 p.m. So let's come back here and let's find the 19th. I know I usually talk about it as the 20th. Because it was almost at mid-tide, let's use the 20th here. 12 hours, 11 minutes. So 11 out of 60 is 0.18. So we've got 12.18. And that happens on March 20th. How about this one? Well, that's in September. Okay, here we go. Nope, didn't go there yet. In September, and what are we looking for? Well, we're looking for fall solstice when it switches back, but we also need to make sure that we're at that 12.18 hours. 12.18 hours. It's going to be right in here. And let's go with September 19th. So that would be 9. Did I say 18th or did I say 19th? I think I said 19th. Yeah. Okay. So we're back to that 12.81. Okay, so we got our graph set up. Now we need to write the function here. So what we need to know is what's our amplitude. Okay. So our amplitude is going to be the difference between those two. Okay. So I'm going to take 15.62 minus 12.18, and that gives me 3.44. Okay. And let me just confirm that by taking 12.18 minus 8.77. Okay, it's not perfect here. That's okay. We're going to have to just settle on imperfection. It's tough to get a perfect model for this. It's just really close. And that's why we call it modeling, is we're just coming up with the best that we can. So 3.41 on that. So I don't know if we want to settle that like a 3.42, 3.43, or just pick the 3.44. I guess because you're not here, I'm going to have to make the decision on that. Let's go with an amplitude of 3.425. I guess that would be right in the middle. All right, so we're writing our function with time. Our amplitude is going to be 3.425. We're using the sine function. All right, so now we're in here. Now we have to realize that we have a different period. Our period is normally 2 pi. What is our period now? This takes a little bit of thought here, doesn't it? And I goofed this up. Yeah, I definitely goofed this up. I don't know why nobody said anything. I've got these in the wrong position, right? Doesn't this have to be back at March 20th again, that's when it repeats. This is a period here of 1 year. I've got these things, I don't even have a date on that one, right? This should be our most daylight there. This is fall, where we're back to equilibrium. This is correct. That is December, where we have our least amount, and then this is back to March again. There we go. That makes sense, right? March, June, September, December, March. Okay, that looks good. So our period here is 1 year. Now, we don't want to use a scale of 1 here. I think what we want to use is days here. So our period, get me out of the way. Our period, now this is 2020, so our period is 366 days. So we're going to set 366 equal to 2 pi over b. So that's pi over, what is that, 183. There we go. Now, we also have to do a phase shift if we want to match up March 20th actually to be March 20th, because right now, if we'd left it like this and we didn't do any phase shift, day 0 is March 20th. And if you want to actually realize that March 20th is a certain number of days in, and you want our function to actually start on January 1st at the beginning of the year, we have to do a phase shift. So one thing I need to know is March 20th is what day of the year. Okay, now I could add these all up, but by the time, I don't want to do that when I'm out in December and September and June. March wouldn't be bad. But I found another website here that will give us the number of days of the year. So I can select March 20th, hit calculate, and that's day 80. So we're going to change this to day 80. June 20th is 172. September 19th $263. December 21st $356. And then we'd hit 366, and that would be January 1st again. All right, so what's our phase shift here? Our phase shift is we need to move this thing 80 units over. Typically, sine function starts at 0. Now we're going to have to slide it over a total of 80 to the right. There we go. Well, actually, come to think about it, if January is day 1, how do we have to slide that over? If January is day 1, and this is at 0, so actually we need to slide that 79, don't we? All right, let's graph it and let's check it out. Oh, I forgot one more thing. We got to move that midline up to, what is our midline? Oh yeah, 12.18. All right, let's graph this and check this one out. All right, so I've got it typed in. Let's try to set an appropriate window here for us. X's will go from 0 to 366. Our Y's are going to go from, let's go 0 up to, what, 20? Oh, I forgot my midline, plus 12.18. There we go. Okay, and looks good. All right. Thanks for watching the video there. We just wrote a function for the daylight hours. Pretty neat thing. Thanks for watching.